All right, so there's many cases about SQL. So in SQL, you can do two ways of writing queries or executing queries. One is you use a prepared statement. So first you have some kind of a statement or some kind of SQL expression, and then you send it to the database and prepare it, right? And then you can set some parameters, execute the statement, and then later on you can use the same prepared statement, set other parameters, run it again. The nice thing about this is that, well, the actual compilation of this query is something that happens only once, right? The other thing that is also happening a lot is just that you execute a query directly, right? So you have the statement here, send it to the database, execute it directly, and do not have all this prepare stuff in there. Okay. Most database libraries offer both of these versions. Not all databases actually do, like SQLite. In SQLite it works like this. So you see these elements that you saw in the code before. So you have a query, you convert that into a prepared statement. This contains a pointer to some internal implementation thingy, and then you generate a result from that, which also contains a pointer to the same implementation thingy. That's where it gets the actual rows from. Okay, it doesn't have the direct execution. In contrast to many other databases, there's nothing like that. So if we simulate direct execution, we actually in the background do exactly the same, right? So take the query, create a prepared statement, and then return the result. This thing here, well, goes away, right? This is something that we don't return. Nobody's interested in that. Which means that if we're thinking about this pointer here, we're in a strange situation, because here it looks as if, well, we have a prepared statement. This has the pointer. This is something that persists, right? Through results, maybe. So we will hold on to this pointer here. Seems like we have here a clear ownership, and this is more like a view. Whereas here, well, this has to own the pointer now, because that thing is gone, right? And if the ownership were sitting with the prepared statement, then you would have a problem. Okay, so the question is, how do we model that an object is the owner of the right? Yes?
What I'm not getting is, like, can't it be like a pipeline, like one thing happens and the next? Like, why does it have to survive? Why does the pointer have to survive like
this point? The prepared statement is represented internally by this thing. And if the prepared statement is something that survives the lifetime of the result, then it has to stay here. Yeah, there are lots of options, right? Bunch of people just answer with shared pointer, because that's the easiest thing to do, right? You don't care about who owns this, and just fuck it and just shared pointer. Okay, but there is no shared ownership really, because in the first part the statement seems to be the owner and the other is just a view. In the second, there's just one thing, and why would I have shared ownership? Okay. Next thing, that if shared pointer is not the solution, then there's always unique pointer. And never do this at home. So unique pointer, you could model this if you wanted, right? You could have a custom deleter that you can configure to either delete or not delete. But this is breaking the mental model that everybody has for unique pointer. Unique pointer is modeling ownership. So yes, technically you can do this. Don't, right? This might also work, right? A variant with a pointer or a unique pointer. I don't know. Tried the other ones. This one I didn't feel like. Then what I also thought about is what about we have two different classes for this, because this thing here, if that is an owner, it has the same interface towards the user. The only difference is the ownership. So this owning result is a non-owning result plus ownership. So we could do something like this. We have a result view that contains just a pointer and a result that derives from the result view and has the ownership here. And then in the constructor we would just pass the pointer that the unique pointer points to the base class and be done with it. Yeah, that works, unless you pass this thing to something that expects a result view, and then you have slicing maybe, and the passed in maybe goes out of scope, and when it does so, right, it is the owner, right? So it kills the pointer, and you have a dangling pointer in whatever you constructed with it. So, and yeah, sure you can try to prevent that, but it becomes ugly. Another one would be a template to say, well, do we have ownership, yes or no? I started doing that and then felt like, I don't know, I can implement the two classes by hand much more quickly than writing all this template nonsense that's required to do this. And that's saying something for me. So, and then you mentioned that earlier, we can move ownership, right? So when you look at this, they are using the same pointer. So when we have this prepared statement and then we create a result from this, the result is reading from the same pointer. It would be a bad idea if this thing in the same time were run again and produce a second result, but because then we would have two competing results working on the same thing. So what we can do is we can just move ownership, basically. So as soon as the result is there, it takes over ownership and then later on passes it back when it goes out of scope, right? Just try to sketch that here. So in the constructor we pass in a unique pointer plus a pointer to the statement, which if it's non-null, then we can just in the destructor pass back ownership, something like that. Again, that is a bit strange, because if then the statement goes out of scope for some reason, you have a dangling pointer again, and I don't know. So I came up with something different, but first of all, my voice is failing. Second, the time is over. And third, I want you to think about this, because ownership is an important thing. I have an implementation, if you want to look it up, it's on GitHub. But otherwise, I'd like to hear what kind of solution you would choose. That's it. Thank you.